Hello everyone. Before we start the lecture, I wanted to show you where you can find our course slides and also the lab's instructions. If you go to this link, this is our course repo, AWS EC2 course under Cloud-Yeti on GitHub, and you can find the slides by clicking on this file, and also all the labs by clicking on labs. You can also ask questions by clicking here. It will take you to the GitHub issues, and you can contact us by emailing us at this email if you have any questions or if you want to reach us for any other reasons. And I'll be linking this in the description below so you can have access to this repo. Thank you, and see you in the next video. Hello everyone. Welcome to this video. In this video, I'll start covering the 20 must-know things about Amazon EC2. So let's get started with fact number 1. EC2 service lets you create virtual machines on AWS. Each machine is called an EC2 instance. EC2 comes from the name Elastic Compute Cloud, or ECC. EC2 instances are elastic, just like in the name, meaning they can instantly grow or shrink to match the requirements of a specific application. So they can grow and shrink in capacity. You can start with 5 EC2 instances and provision hundreds and thousands as needed. And it ties up to the concept of pay as you go, right? You can pay for your EC2 instances as you go, and you don't have to buy capacity up front. You can absolutely pay as you go for EC2 instances per second. So if you use EC2 instances for 5 minutes, you pay for 5 minutes. If you use EC2 instances for 5 hours, you can pay for 5 hours only. So you get the capacity whenever you want, and you only pay for what you use with EC2. Some of the features of Amazon EC2: it has an option for persistent storage volumes by using elastic block storage. You can attach multiple elastic block storage to your EC2 instances. You can place your EC2 instances in multiple availability zones. Those are, miles apart from each other, and place EC2 instances in different regions, right? These are Amazon's global infrastructure, right? You can place your EC2 instances in Sydney, in the US, in Brazil, and so on and so on. So you have this option to place your EC2 in multiple physical locations. You also have this feature of security groups, which are firewalls that control traffic to your instances. You can have static IPv4 addresses called elastic IP addresses. You can also add metadata known as tags to your EC2 instances. And you can select the size of your EC2 instances, right? You can provision a small EC2 instances with 1 gigs of RAM, 1 CPU, and you can also provision an EC2 instances with 4 terabytes of RAM. Fact number 2, in order to create an EC2 instance, we have to have an AMI. AMI stands for Amazon Machine Image. AMI is basically an OS image, and it provides the information required to launch an instance. Now let me go to the AWS Management Console, and in here under Services I'll find EC2, and then I'll click on Launch Instance to start launching an instance so that I can demo the process to you. Step number 1, I'm asked to choose an Amazon Machine Image, or an AMI. An AMI is a template that contains the software configuration, operating system, application server, and applications required to launch your instance. So we talked about this. You can select an AMI provided by AWS, the community, marketplace, or even your own AMI. So the first thing that I do before I can launch an instance is I choose an AMI. And we talked about the types of AMI, right? AWS provided AMIs, AWS Marketplace AMIs, your own AMIs. So we have listed all this in here. And you can browse through those different types of AMIs by clicking on the left navigation pane here. Quick Start is the AWS provided AMIs. My AMIs are your AMIs that you would create. AWS Marketplace AMIs can be accessed by clicking here, and community AMIs can be accessed also right here. Let's go back to the Quick Start. So there is an Amazon Linux AMI, which is supported and maintained by AWS. The Amazon Linux AMI comes with a lot of AWS developer tools like the AWS Command Line interface, the Boto 3 library, etc. It also comes with access to packages such as MySQL, Python, Tomcat, etc. So this is something that we'll be using over and over in the labs. And Amazon Linux AMI is right here. And this is different than Amazon Linux 2 AMI. Keep this in mind, right? We'll be using a lot of this AMI in our labs. Fact number 3, you choose the size of EC2 by selecting a type. There are different types of EC2 instances. So let's go to the EC2 launch process. After you chose the Amazon Linux AMI, after we choose an AMI to use to launch our instance, when I select this, the next step or the next page I'm taking to is choose an instance type. Now, depending on what type of instance you choose, you get a configuration of memory, the number of CPUs, the network performance, etc. Right? So if I needed a server that had 8 gigabytes of RAM, I would choose something like a T2 large, or even T2 extra large. But if I only needed the bare bones, just a small server, that does a simple thing, then I probably go with T2 Nano, which gives me half gigabytes of RAM, 1 CPU, and I'm okay with that configuration, right? So if you want something very powerful, you can go with the X1E.32 extra large, which comes with 3900 gigabytes of RAM. That's almost 4 terabytes of RAM, and also 128 virtual CPUs. So, there's a lot of options for you to choose from. You can select whichever fits your needs. In our case, we're good with T2 Micro, and this is also under free tier. So we'll be sticking with this most of the times in our labs. So the next fact is there are certain things, components, other than the AMI and the instance type, that you need to successfully launch an EC2 instance and also log into it, right? So for you to be able to launch an EC2 instance and log into it, you need to make sure there are certain things selected properly. One of them is VPC and subnet. Going back to the EC2 launch process, once you select the instance type, T2 Micro, and say next, you get to select all these things, right? And these are some of the things that I'm talking about right now. So you need to select a network. A network is your VPC. Your account comes with a default VPC, so you don't actually need to create a network. It also comes with a default subnet. So if you don't specify anything, you go with the default VPC and the default subnet. Now this is page number 3. You can go back and forth between pages by clicking here. If you go to page number 4, you also need to add a storage, right? You also need to select a storage. The AMI template comes with a root volume. So most of the times you may just proceed without changing anything, but it is actually included in the launch process, as you can see here. Now the other thing that is required is the security groups. Security groups are firewalls, set of firewall rules that control traffic for your EC2 instance. And finally, in the last page, when you review everything and you click on launch, you also have to select a key pair, right? A key pair consists of a public key and private key. You download the private key and AWS keeps the public key. When you launch an instance, you say which key you want to use to log into that instance. And depending on that, you can log into that instance. So if I launch my instance with the first instance key pair, right? Then I can use my first instance private key to log into the EC2 instance. So these are the components that you need to launch an instance and log into it successfully. Fact number 6 that you must know about EC2, the EC2 life cycle. You have to know what stages a EC2 instance can be in. So if I go back to my instance, I'll cancel this out and really quick do a review. We chose an AMI, we chose the instance type, we configured the instance. We went with the default options in this page. So next, add storage. We didn't change anything here, but we went with the default option of 8 GB of EBS volume. We didn't add any tags, so this is optional, but I'm going to add a tag, a name tag of demo EC2. And then I will need to add a security group. I either need to create a new one or select an existing one. I'm going to create a new security group and just say review and launch. Launch. I'm going to select my key pair and launch, right? So this is just a sample launch process, right? I just launched it, but if I quickly click on this instance ID, then you'll see the instance state is pending. Pending. Going back to the slides, when you launch an EC2 instance with an AMI, it goes to a pending state. After a while, it will go into a running state. It did go into a running state. After it goes into a running state, you can reboot your instance, you can stop your instance, or you can terminate your instance. You can also now hibernate your EC2 instance, but these are the EC2 instance lifecycle states that you have to know. You can read the differences between what happens when you reboot, stop, hibernate, and terminate your EC2 instance by going to this link. Fact number 5. There are 2 kinds of EC2 storage: instance store and EBS storage. Your EC2 instances are virtual machines living in a physical box, right? So instance store volumes are storage that are attached in the physical machine where your EC2 instance lives. So you have limited amount of quantity available, you have limited size available, and these are the older types of volumes. On the other hand, EBS volumes are networked volume that live away from your physical machine, and you can add multiple EBS volumes to your EC2 instance. So you have 2 options to choose from when it comes to storage. Most of the times we will be using EBS volumes, but we do have a lab on instance store EC2 instance. We'll look at fact number 7 in the next video. Thank you for watching. Welcome back. We stopped at fact number 7. Let's look at number 7 now. The EC2 pricing model. You have to know about the EC2 pricing model. The EC2 service gives you 3 pricing models. One of them is on-demand instances. This is where you rent your EC2 instances for a few seconds or hours or days. You just pay as you go. You pay as you go. It's going to be expensive. This is the most expensive option because you're just paying as you go. And if you knew that you need an EC2 instance for, an extended period of time from at least 1 year, then you would probably want to reserve your EC2 instance. When you reserve EC2 instances, you pay upfront for 1 to 3 years, and the more upfront you pay, the longer the term is, you end up saving the most. You're getting a big discount with reserved instances. So if you have a workload that is gonna be running for extended period of time, then you want to look into reserved instances. The third option you get is spot instances. Now, spot instances are instances that may or may not be available for you to use. If it's available, you bid on them. Now, these are spare capacity that AWS has at any time. If there are some spare servers, then you get an opportunity to bid on them. you can use them, but AWS can terminate your instances with a 2-minute of notice. And because of this arrangement, you get up to 90% discount on the cost of EC2 spot instances compared to on-demand instances, right? You have to bid on them if available, and you may get a big discount when using spot instances. So depending on your workload and depending on your needs, you can use a mix of on-demand, reserved, and spot instances to make better utilization of the resources and control your cost. Let's look at fact number 8. You have to know about the EC2 Tenancy Model. The EC2 Tenancy Model tells you whether the virtual machines that you launch, if they are on a shared host or if they are not shared with anyone. So in the cloud, when you launch an EC2 instance, many other users are also probably sharing the same host machine as your EC2 instance is, right? So with dedicated instances, only your virtual machines can be in a physical machine, a host machine, but you end up paying more for this option. And within the dedicated types of instances, there's dedicated instance and dedicated host. Dedicated host give you the most control over your physical machine. If you have strict regulations and requirements, like if you're in the defense industry or banking industry, you can look into the dedicated option. Let's look at fact number 9. When an EC2 instance is stopped, right? So we looked at the instance lifecycle earlier, but you have to know that when your EC2 instance is stopped, certain things happen. The private IP remains with the EC2 instance, but the public IP goes away. You cannot expect to keep your public IP if you stop your EC2 instance. Now that's unless you have an elastic IP attached to your EC2 instance, and that's another thing. But most of the time, the default public IP that you get goes away when you stop an EC2 instance. The underlying host, the physical machine, may also change when you stop an EC2 instance and restart later. So you have to keep these things in mind just to understand, how EC2 works and what happens when you stop. You can go to this link to learn the differences and the nature of what happens when you stop, terminate, or hibernate EC2 instances. Let's look at fact number 10. We talked about public IP in the last slide, but let's look at this once again. When you launch an EC2 instance, let's look at the EC2 instance we launched earlier. If I click on my running instances, this demo EC2 instance that I launched earlier got a public IP address. This is the public IP address. And it has a private IP address. What if I stop this instance? Keep a note of the IP, 3.95.31.250. After a while, when the EC2 is stopped, if you look down, the public IP address is gone. The private IP remains with the instance, but the public IP is gone. And if I restart the instance now, if I start the instance once it's stopped, we will very soon get a new public IP address. Most likely it's going to be different from the one it had before. And as you can see, the IP is different than the one before. If you go back in the video and see, you'll see that the IP is different. The IP that goes away is the EC2 public IP address. Now, if you don't want this public IP to go away, you would use something called the elastic IP. The elastic IP is simple to provision. You just click on allocate new address and you click on allocate, and there's a new IP address allocated for you. And then you can quickly click on actions and associate the address to your instance, associate. And at that point, your EC2 instance has an elastic IP. You see this blue IP address, and when you stop an EC2 instance with an elastic IP, the elastic IP stays with the EC2 instance. But when an elastic IP is attached to an instance that is not running, you pay for the elastic IP. When the elastic IP is attached to an instance that is running, you don't pay. right? Basically, if it's not running, you pay for it. So that's something you need to know about public IP and elastic IP. Let's look at fact number 11. You can turn on termination protection on your EC2 instances to protect them from being accidentally deleted. In the cloud, resources are easy to launch, but also easy to destroy, right? If you want to protect your EC2 instances from accidental deletion, let's say someone comes to my account and just is playing around, and while doing this accidentally clicks on terminate, and somehow actually ends up clicking on terminate, right? There's only two places you had to click. But what I can do is I can enable termination protection on this instance by going here, change termination protection, and I can enable termination protection. So when I go and try to terminate this EC2 instance, I cannot, and I have to disable the termination protection first. So this way you have an added layer of security before someone can turn off your instance, either accidentally or intentionally. Let's look at fact number 12. You can view the EC2 instance metadata by visiting this URL from inside the EC2 instance, 169.254.169.254/latest/metadata. So not only this will be helpful when you're working inside your EC2 instance and you want to see some of the metadata. This IP is important to remember. In fact, the whole path is important to remember while working with AWS. And you can look into metadata like IAM Credentials, the IP address, the AMI ID, the instance ID, etc., etc. Let's look at fact number 13. You can run commands on your EC2 at launch using a Userdata section that's provided to you in the launch process. In page number 3, during the launch process, there's an advanced details section. And if you click on advanced details, this box will pop up, the Userdata box will pop up. And here you can paste in your script, right? It can be a bash script or it can be a PowerShell script in case of Windows. And you can paste in certain scripts that will run during startup. So before you go to your EC2 instance, after you launch, something will already be executed. The scripts that you want or the commands that you want will be executed beforehand. And we have a lab on this coming up, so we can do this together. Let's look at fact number 14 in the next video. Thank you so much for watching. Welcome back. Let's look at fact 14 that you must know about Amazon EC2. You have to know about EC2 monitoring. Cloudwatch is a service on AWS that provides basic monitoring for various EC2 instance metrics like CPU utilization, network in, packets in, and disk read and write metrics. But Cloudwatch does not provide other metrics like memory utilization, and you can collect custom metrics using Cloudwatch agent or some other agents if you want to. But by default, memory utilization is not provided by Cloudwatch. You can also collect logs from your EC2 instances using the Cloudwatch agent, and we have a lab on Cloudwatch agent, so we can work with Cloudwatch agent there. If you go to your EC2 instance, the third tab will show you the Cloudwatch monitoring metrics. So let me go to my EC2 management console. And by default, you'll always see the description of the EC2 instance. But if you go to the third tab, in the monitoring tab, you get to see the CPU utilization, disk read, disk writes, and you can click here to view all the Cloudwatch metrics, and this will take you to the Cloudwatch management console, which is the service monitoring the EC2 instances. Fact number 15, you have to know about IAM roles that you can attach to EC2 instances and give permissions to your EC2 instances. Even if you are working on your EC2 instances, you cannot access files on S3 if you don't have permissions to do so. And you can add permissions to work with S3, two ways. One, you can hard code the credentials. You can generate your access key ID and secret access key, and then you can hard code the credentials using the AWS configuration tool, or you can hard code it in the code and call AWS services. But a better way would be to use IAM roles, and the roles will have the necessary permissions to work with other services like S3 and DynamoDB. And this is usually safer because roles use temporary credentials using the security token service, and they live short term, so they are safer. We have a lab on roles and access keys coming up, so you can have some practice on this topic. To add the roles, you just select the instance, you click on Actions, Instance Settings, and attach Replace IAM Role. Let's move on to fact number 16. You have to know about snapshots. Snapshots lets you back up your data that live on EBS volumes. EBS volumes are the volumes attached to the EC2 instances. If you take a snapshot of your EBS volumes, that snapshot will let you create a volume out of it. Just like an AMI lets you create an EC2 instance, the snapshot will let you create EBS volumes so that you can restore your data once again. Let's look at fact number 17. We talked about this, but you have to know about custom AMIs. You can create a custom AMI or Amazon Machine Image, and this is also called pre-baking your AMIs. And basically this means that you can install custom applications that's tailored to your needs, to your business needs, so that on top of the operating system you can install specific applications and you can use that AMI over and over to launch more instances. So this is your custom AMI. This is called pre-baking an AMI, and we have a lab on this so you can practice this concept of creating an AMI. Let's look at fact number 18. You can interact with EC2 by using these methods. Obviously, we have been using the management console to work with EC2, but you can also use the command line interface where you type in some simple commands and you can interact with EC2, describe, list, create, delete. We have a lab on this. You can also use CloudFormation to provision EC2 instances and also destroy EC2 instances that are created by CloudFormation. You can also use AWS Software Development Kit to work with EC2 instances, and also the AWS REST APIs. We'll look into the command line interface in one of our labs. Let's look at fact number 19. You have to know about EC2 autoscaling. With autoscaling, you can automatically increase the number of EC2 instances when the demand spikes and maintain the performance, and also decrease capacity of EC2 instances when the demand goes down to reduce costs. You can set up Cloudwatch alarms that trigger your EC2 instance to add in capacity. Right? So when you have servers being heavily utilized, then based on the load, you can keep on increasing your EC2 instances. So this is a feature that EC2 gives you to create autoscaling groups. You can combine autoscaling with ELB or the Elastic Load Balancer to create a robust and fault-tolerant architecture. Let's look at fact number 20. You have to know about the EC2 instance free tier. AWS for new users gives you a lot of free tier benefits. That includes 750 hours per month for the first 12 months of free EC2 instances of T2 micro type. So you can have one EC2 instance run for 24 hours, 7 days a week for 365 days without paying anything. Now, if you end up, letting people download a lot of stuff, then you may end up paying for the data transfer cost. You get a free EC2 for a year and also a lot of other services for free for a year. So please go out there and practice, utilize this free benefit. Thank you so much for sticking with me in the lecture. We have labs coming up next. See you in the next video. Hello everyone. Welcome back. Let's start doing lab number 1 by going to the labs folder in our course repo. So I'm going to click on labs, and then I'll be taken inside the folder where there's 10 different files for each lab that we'll be doing. I'm going to start with lab 1. You can see the steps for lab 1. But first of all, let's log into our AWS Management Console, and then we will launch an EC2 instance. So once you're in the Management Console, if you click on Services and EC2, then you should be able to go to the EC2 Management Console. From here, click on Launch Instance, and you'll be taken to step number 1. Choose an Amazon machine image. Let's select the Amazon Linux AMI, and keep in mind that this one and this one look very similar. We want to select the Amazon Linux AMI and not the Linux AMI 2. So I'm going to select Amazon Linux AMI, which means we'll be launching a Linux instance. Select, and the second step, or step 2, or also page number 2, you can see that there are tabs or pages. You can go back and forth. Step number 2 or page number 2, you select an instance type. Instance type lets you choose the size of the resources that you want to provision. So this is like a knob to get prepackaged amount of CPUs and memory. For example, if you select T2 Nano instance type, then you get 1 CPU and half gigs of RAM. And also option for EBS storage only. The network performance of low, so not so good network performance, not so good RAM. So if you want, let's say 8 gigabytes of RAM for your application, then you just look down this table and find the number that fits your needs. Then maybe you select T2 large for your application, and so on and so on. There's all the way from half gigabytes to the maximum of 3,900 gigabytes, or about 4 terabytes of RAM available. And if you were to select the highest RAM instance, that would be X1E.32 extra large type. So this hopefully gives you what the type selection does. And we want to go back and select something that is enough for our needs. Especially we want to select the T2 Micro, which is under the free tier. So I'm going to select T2 Micro, which will give me 1 CPU and 1 gigabyte of RAM. So I'm going to click on Next, which will take me to page number 3 or tab number 3. Here I select number of instances, that's 1. This is the network or the default VPC that's already built for us, so we don't need to change anything here. No changes here, no changes here. And then for now we want to leave everything as it is, but we can quickly browse through some of the things. For example, IAM role will give ability for the EC2 instances to call AWS services without using access keys. So this will give permissions to our EC2 instances. We don't want to do anything with this now. Shutdown behavior lets you say what happens when you stop your instance. Do you just want to stop the instance or terminate the instance? Termination protection gives you one added layer of protection against accidentally deleting your EC2 instance. So it's a good idea to turn it on. The monitoring checkmark gives you enhanced monitoring options, which will cost more. Tenancy is whether you're sharing the host or not, whether someone else is also running EC2 instances on the same physical machine as you are. So once again, T2, T3 unlimited. Whenever you select the instance type of T, which are burstable EC2 instances, they can only stay at 20% CPU utilization or so, and they cannot run more than that for extended period of time. And this will give them extra capacity as needed if they need to burst. I'm going to link something so that you can read more on this topic. All right, so with that, Let's go to next and add storage. So step number 4, you add storage. You can add a number of volumes of different sizes. You can detach the volumes and attach them as needed from the EC2 and have them persist independently of the EC2 instance. And you can do many things. But for now, we just want to stick with the default option, general purpose SSD volumes. I want to say next add tags. And tag is just tagging your instance for various purposes. For example, if you say name, then you get to say my first instance or something, so that you can identify what instance is. So literally tagging what it is. But you can also tag things like department and IT or project ID and say 555 and so on and so on. So you can do many things and tag each resources. This is optional. I recommend you at least add name tag. Let's say next, configure security group. Security groups are firewalls for your EC2 instance. Let's create a new security group and call it first instance. Right now, port 22 is open to the whole world, which this IP tells us 0.0.0.0/0. It means anyone in the internet can use port 22 to SSH into the EC2 instance. I'm going to add one rule to also allow HTTP port 80 from anywhere. So I'm going to click on review and launch and scroll down, review everything, see the instance type, security groups, the details, the AMI, verify the tags are right. You can see the storage, some more instance details. And after you verify everything, click on launch. At this point, you probably want to select create a new key pair option from here. If this is your first time doing this, the key pair name will be first instance. Download the key pair. And then after you download, you can launch instances. After you launch the instances, you go back to your EC2 dashboard and click on connect. You can go back to the EC2 console, or you can also click here on view instances, and this will take you back to the EC2 dashboard and will actually take you to the instance that we just launched. And at this point you click on connect, and then you'll be able to see this window. You want to copy this text under example, which will be filled with your IP right here, and your DNS name and your key pair that you downloaded earlier. You close the window and you're ready to paste that into your terminal. So for Windows users, you have to install one application called Git Bash, or an application similar to that will let you use the SSH command and log into Linux servers. So you just want to install this and open this application, which will open a terminal like Linux or Mac, so that we'll all be on the same page. So I'm here in my terminal, and before you log in, the thing that you need to be careful is you need to be on the same directory as the PEM file that you downloaded earlier to SSH into the EC2 instance. So for everyone on a Linux machine or a Mac machine, command like cd downloads should take you to your downloads folder, and this is a sign representing your home directory. So the downloads folder of your home directory is usually where AWS downloads your key file that we created earlier. For Windows users, what you can do is you can go to your downloads folder and right click, and you'll see this dialog box, and in this dialog box you just click on git bash here, and it will take you to the git bash terminal with the downloads folder as your working path. So once you're in the downloads folder, I'm gonna type something to secure our keys. I'm gonna type a command that will secure our PEM file or key file that we downloaded earlier. The command is chmod 400 first instance.pem, enter. And in your case, you can find this command, and the place that I got this command is if you go back to your EC2 management console and click on connect by selecting the instance that you launch. Step number 3, it will tell you to enter this command first, right? chmod 400, and what this will do is it will make this key available only to the current owner. 4 represents read permissions only to the owner. And after I enter this command, I'm ready to copy this command again, and I'm going to paste this command. Now, the IP that I see here won't be the same in yours because your IP address is different than mine, and the key name will be different on yours. So you copy this, come back to your terminal or your git bash if you're on Windows, and type enter, and you should see a sign like this that will tell you that you're on an Amazon Linux AMI, and we are logged in to our EC2 instance. And at this point you can do a few things like ifconfig and check the IP address, and this is my private IP, which is also here, by the way, 172.31.83.6. And if you go back and select the instance, this is the private IP that you see. So you're currently logged into your EC2 instance, and hopefully you learned some things in the way, because we looked at a few different components while launching the EC2 instance. All right, this is the end of this lab. Thanks for watching, and I'll see you in the next lab. Welcome back. In the last lab, we launched a Linux EC2 instance, and in this lab 2, we will be creating and logging into a Windows EC2 instance. So let's go to our labs folder on the course repo and click on lab 2. Once you're in this page, you can look at the steps, and once again the objective of this lab is to create a Windows EC2 instance and log into the instance with RDP, or Remote Desktop Protocol. So I'm going to log into the EC2 console, and if you have an instance open from our last lab, then I suggest we all select this and click on Actions, Instance State, and Terminate, which means release forever. I don't need this anymore. I'm going to click on this and click on Terminate. So this way we do some cleanup, and then we can move on to launching new instances. Alright, so once I terminate this instance, it's going to take a while for this to go away. So I'm going to click on Launch Instance for our second lab. And this time, I'm going to type Windows in this box right here. Now this will give me a few options to choose from, but I want to select the Windows 2016 base. Now this is not so important, but to be consistent with me, you can select this one, but you can also go ahead and try some other options if you want. But the name of the AMI that I want to choose for Windows EC2 instance is this. I'm going to click on select, and once again I'm going to select the T2 micro. Click on next. I'm going to leave everything as it is. We talked about these things in the last lab. I'm going to click on next, add storage. Now if you notice here, compared to last lab, the minimum size of the EBS volume that you can have, the volume that you can choose is 30 gigabytes, and this is because Windows is a bit larger than Linux. I want to say next, and let's add a tag. Say this is a Windows instance, and click on next, configure security group. Now this time you won't see SSH like last time, because SSH only is for Linux instances. For Windows instances, by default there will be a rule for RDP on port 3389 coming from anywhere on the internet, and that's fine for now. I'm gonna rename this Windows SG for Windows Security Group, and review and launch. You can once again review, all the options that you selected, all the features that you chose, and after you verify, click on launch. And I'm going to select the same key pair that I used earlier for lab number 1, the first instance for me. In your case it might be different. Let's select one of the key pairs and click on launch instances. At this point you should wait about 3 to 4 minutes for this instance to be ready to RDP. In the meantime, I'm going to click on the instance name, which will take me to the EC2 Instances dashboard. To get here, you can also go to the EC2 dashboard, and on the left navigation pane, click on Instances, and you'll be given a list of your instances. Right now we only have one, so I'm going to select this instance and click on Connect. Now you see this box is different than what a Linux box has when you click on Connect, right? For Windows, what you need to do is you need to get a password, right? You need to get a password. So get password, and you might see a box like this saying the password is not available because the EC2 is not configured, and it will tell you right here that you should wait about 4 minutes after launching the instance. Compare this to a Linux instance, and Linux instances are sometimes ready within a minute of launching. But anyways, let's wait for a couple of minutes and we'll try to generate the password one more time. So it's been a few minutes and I see the status checks 2x2 check mark, which means the instance has passed the status checks. And I'm going to click on Connect one more time and click on Get Password. Now this time I will be taken to this window, which asks me to choose a file that I can use to decrypt the password. So this is the PEM file that we downloaded earlier, in my case named firstinstance.pem. I'm going to click on Choose File. So I'm going to choose the .pem file. After you choose the file, you can click on Decrypt Password, and then you will be given a password. You can click on this button to copy this to your clipboard. Once you copy the password, you want to click on Download Remote Desktop File. Right? You click on Download Remote Desktop File, and then you'll be able to click on this downloaded file, and a Windows Remote Desktop application should open up. If you're on Windows, this will be installed by default. If you're on Mac OS or Linux, if you don't have this, then you can download this by searching for Microsoft Remote Desktop application. I had this installed, and I have also installed another version of this. So, depending on if you have this or not, you can go ahead and make sure this is downloaded. Once you click on this downloaded remote desktop file, you'll be taken directly to a window like this, and you'll be asked to verify that you want to continue. So I'm going to click on continue at this point. It's taking a while, but there it is. Please wait for the local session manager. And the username is administrator. The password is the password that I copied earlier. Sometimes the password cannot be pasted. So what you need to do is, unfortunately, type everything that you saw earlier in the window. So I'm going to do back and forth and paste in the password. So once I enter the password, I'm going to click enter, and looks like the password was accepted. Great, because I don't want to type that again. And there is my Windows machine ready to use. This is my EC2 instance, and you can see there's some EC2 specific files like the guide and feedback, and you can play around with this. But this is the end of our lab number 2, where we just launched a Windows EC2 instance. Thank you for watching. I'll see you in the next lab. Welcome back. In this video we will be doing lab 3. So I'm going to go to the course repo, and inside the labs folder click on lab 3. The title of this lab is Install the Apache Web Server in the EC2 instance and create a golden image from that EC2 instance. So Apache Web Server is one of the most popular web servers, and it's 20 years old. So Apache Web Server is a HTTP server, and you can host your websites on this. We will be hosting a simple website on this server, but before that we need to install this server, and even before that we need to launch an EC2 instance. So I'm going to go to my EC2 management console and click on launch instance. Now this process is similar to lab number 1, where we launched Amazon Linux AMI. So I'm going to select this option, Amazon Linux AMI, and stick with the T2 micro instance type on page number 2. Click on next. In here I will leave everything as default and click on next. The storage will stay as 8 gigs. Click on next. For the tags, I like having tags on my resources, so I'm going to name this EC2 Linux because this is a Linux EC2 instance. So next, configure security groups. We did create a security group in lab 1 that has port 80 and 22 open. We can choose this, stick with this, or if you want you can create a new security group just like we did in lab 1. I'm going to stick with the first instance security group that we created in lab 1. Click on review and launch. At this point I'm going to click launch and select the SSH key that I generated in the first lab. Click on acknowledge and launch instance. At this point I can click on view instances by scrolling down, and I have 1 pending instance and 2 instances that are terminated. Now this is a quick tip for you. If you don't like seeing these terminated instances, what you can do is click on this box, and this will let you filter by instance state and many other options. But for now, if you click on instance state and say running, right, it will only show you running instance, and this will be a lot more cleaner. Okay, so once you see your instance, it should take about a minute for this to be ready. So you can actually click on connect and copy this example phrase that you are given. I'm going to copy this. I'm going to go to my terminal, or git bash if you're on Windows, and on my downloads folder. This time I don't have to chmod 400 because I used an existing key pair that I already performed the chmod 400 command to, so no need for this. I'm going to paste this string, this phrase, in the terminal window and click on enter. At this point I will be given this option to choose yes or no. Are you sure you want to continue connecting? I am, so I'm going to say yes, and once again I'm going to see this this drawing of EC2 and text that says Amazon Linux AMI, which means I'm inside the Linux AMI. Alright, so once I'm logged in, I'm ready to download the Apache Web Server. Let's go back to our GitHub steps, and you can copy this command that will install the Apache Web Server. This is the command using the Yum Package Manager on the Amazon Linux. If you were on Ubuntu or some other Linux distributions, you could be using apt-get, but for now, since we're using the Amazon Linux EC2 AMI, we have to use yum. So I'm going to copy this command and paste that command, which will install the Apache Web Server. And you should see a message saying complete. At this point, the web server is installed. Now we need to do a couple of things. First of all, you need to start the Apache Web Server or the HTTPD service by copying this command, sudo service httpd start. So I'm gonna come to my terminal and paste that. You should see a message saying starting httpd okay. That means the server is started. After you start the HTTPD or the Apache Web Server, let's move on to the next step. So let's just copy this command, sudo check config httpd on. That will make sure that Apache Web Server is started when your EC2 is restarted or started. So I'm going to copy this command, go to my terminal and paste sudo check config httpd on, enter, and this will make sure the setting is turned on. You don't see any message. That means that it probably worked. So once you do this, let's go to the EC2 dashboard and let's select the instance. Let's go to the EC2 dashboard. Let's select the instance, and on the lower side, on the bottom portion, the description tab of the bottom portion, let's copy the public IP of this instance and copy, and you can right click, copy and paste, or click on go to if you have this option. I'm going to click on this. This will take me to this IP address on my browser, and if I type in this IP on my browser, I will see this Amazon Linux AMI test page, and this is powered by the Apache Web Server. So this file is actually hosted on the Apache Web Server that we just installed. So this page is the default Apache Web Server index page. So if you wanted to host your content instead of this page showing up when you type in that IP on your browser, what you can do is you can go to your terminal and you can copy this line, echo hello, this page is hosted on my AWS EC2 Linux instance, and by using this line will be saved to this file at var html/index.html. And before you write this phrase to this file, you need to have permissions to do that. So we're gonna use this command to become the root user so that we have access to write a file in this directory. So I'm gonna copy this sudo su dash command, right? And now you can see the user being changed to root instead of EC2 user. So I'm the root user now, and I can come down here and copy this command and create this index.html file. So I'm gonna paste this command. This command just wrote a file in this location. So to verify, I can copy this part and say cat space the path, and I can see hello, this page is hosted on my EC2 Linux instance. So if I go back to this test page and refresh, you should be able to see the messages that we typed in the index.html file, or we saved in the index.html file when we use this command, right? This command wrote this message to this file, and since this is the index page that the Apache Web Server will be looking at to serve the files, I see this message of hello, this page is hosted on EC2 Linux instance. At this point, right, I have an EC2 instance and I installed a web server on this, so I put some work, and I also wrote a file that has this message. And what if I want to come back after 1 year and launch exactly the same type of web page without doing this again? So I can do this thing called create an AMI or Amazon Machine Image from this instance, right? if you remember, while launching this instance, we had to choose an AMI. Now, we will be creating an AMI from this instance. So not only the OS settings or the operating system settings will carry over, but also the application settings, like the Apache Web Server will already be installed, will be running, and will contain this file when we launch the instance with that AMI. So to create an AMI, you go to your EC2 instance, click on Actions, Image, and Create Image. Let's give this a name of Apache Web Server and a simple description. Let's select this option, by the way. And you can click on Create Image at this point, and the Create Image request was received. You can view the pending image by clicking here. So at this point, your image is being created. After a while, the status should be available. And at that point, you can start using the AMI to launch instances. So let's wait for 1 more minute and we can resume. All right, so after a while, the status is available. So what I can do is I can go to the left navigation pane on the EC2 console and click on AMIs and select the AMI actions and launch, or I can also go to the EC2 dashboard after I create the image, and just like we did earlier, we can click on launch instance. Now this time, instead of the default place to select the AMIs, we created our own AMI earlier, so I'm going to click on my AMIs this time, and just like we named it, Apache Web Server is present right here. I'm going to select this and select T2 Micro, click on next, and this will take us to page number 3. Leave everything as default. Add storage, 8 GB is fine, or 8 GIB is fine. Add tags. Now just to be able to differentiate the two servers, I'm going to name this and tag this as launched from golden image, or EC2 launch from golden image. So next, and I'm going to select the existing security group, first instance that has port 80 and 22 open. You can create a new security group with these rules if you don't have one. Review and launch. Click on launch, select the key pair, and acknowledge and launch. At this point, you can click on the instance ID here. This will take you to the instance. Let's give this instance a couple of minutes to get started. We can browse the public IP of this instance in a couple of minutes and see what we get. Right, so it's been a couple of minutes since we launched this instance. So I'm going to click, I'm going to copy the public IP of this instance and click on go to. And when I, type in the IP or browse the IP of this newly launched instance, right? If you have only this selected in the filter, if you cross everything in the filter box right here, then you should be able to see all your EC2 instances. And right now we should have at least 2 from this lab, right? The EC2 Linux is the one we launched earlier. The EC2 launch from golden image is the one we launched later. So when I select the IP of the second instance that we launched, we see the same message that we set in the first instance, and that's because we created a golden image, right? The golden image is an image that we custom create by saying create image, and we can save all the applications that are installed, and not just the applications, the application settings inside the files are also saved exactly like it is. So you can just use this AMI, give this to anyone, and they should be able to launch the same exact server like you have, or like you had when you took the image, when you created the image. So with this, hopefully you get an idea of what a golden image is, how to create a golden image, and also, first of all, how to install a web server and get a web page, a custom web page running on your EC2 instance. So with this, we've come to the end of this lab. Let's go to our EC2 instance and let's do some cleanup. So I'm going to go to my running instances. I'm going to select both of them, click on Actions, Instance State, and Terminate. Yes, I want to terminate them, and should clean up in a bit. Thank you so much for watching. I'll see you in the next lab. Welcome back. This is lab 4, and the title of this lab is EC2 Permissions using access keys and using roles. So 2 ways for EC2 to get permissions to access other AWS services, one with roles, the other with access keys. I'm here in the course repo, and I'm gonna go to the labs directory and open lab 4. So before we give the EC2 instance permissions with IAM role, we will give EC2 instance permissions with hard-coded access keys and secret access key. So you'll get to see 2 ways of giving an EC2 instance, permissions to access other AWS resources. So let's begin the lab. Let's go to the IAM dashboard, first of all, where we will create a user and generate access keys for that user. So I'm going to go to my IAM dashboard by typing IAM in the search box and clicking on IAM. At this point, I'll click on users and I will click add user. I'll use the name of test user 2 and I'll give this user programmatic access. So programmatic access, we need this. Management console access, we don't need this for this lab. So let's click on next permissions, and in here I'm gonna click on this third option to attach existing policies directly to this user. So in the search box I'm gonna type S3. We want to give this user Amazon S3 full access. Once you select the Amazon S3 full access, make sure you select the right one because you also have a S3 read-only access. Select the right policy and click on next tags. In here, just click on next review and you can click create user. At this point, you'll see this window with a button that says download.csv. If you click here, a CSV file with the username, the access key ID, and also the secret access key, which you can view by clicking on show. So once you generate these keys, you can copy and paste these somewhere safe. I'm gonna leave this window open for later when I need this. So the next step will be to launch an EC2 instance. So I'm going to go to my EC2 dashboard and launch instance and select the Amazon Linux AMI, go with the T2 micro, everything default in here, everything default here, and say name it access keys test or something, and say next. Security group can be the existing first instance security group or the security group we created in the first lab, or you can create a new security group. As always, feel free to try a few different things. So now let's click review and launch, review everything and launch with the right instance. Keep here, acknowledge, launch. So just like the previous labs, we have created one more EC2 instance, and I hope you're having fun doing this, because it really will reinforce all the things while you do things again and again. So I'm going to click on this instance and click on connect to this instance, copy this connection text and go into my terminal. I'm in my downloads folder. So let's paste that text to connect, say yes here, and you'll be in the Amazon Linux AMI. At this point, we want to type in AWS. So one thing about the Amazon Linux AMI that we have been using over and over to launch EC2 instances, one thing about those AMIs is that it comes loaded with all the Amazon packages and applications, like the command line interface for AWS, the SDKs for AWS like Bodo 3, and so on and so on. And it also comes with other popular packages pre-installed, compared to Red Hat, with which might not have many things installed. More like bare bones Red Hat versus a bunch of applications installed on the Amazon Linux. So back to the terminal. The Amazon Linux AMI has the AWS command line interface installed. That's why when you type AWS, you see this. Otherwise, if you just log into a normal Ubuntu instance, then AWS, when you type AWS, the command is not recognized because you haven't installed anything. We won't look into installing AWS command line interface in this lab, but we have the AWS command line installed if you use the Amazon Linux AMI. And once it's installed, using it is very easy. You need to type a simple command like AWS S3 MB for make bucket, and type in EC2. Oops, I missed S3://. So you can try to make a bucket. I'm gonna introduce some random strings to randomize the bucket name. So I try to make a bucket using this command. Enter. Right, and I get an error saying unable to locate credentials. This is expected because so far AWS command line interface is installed, but I need permissions to access S3 buckets even if I'm inside my AWS account. That's how AWS permissions work. You need permissions between services. To add those permissions, I can configure the AWS command line interface by typing AWS configure, enter. And here you'll be asked for the AWS access key ID. And this is where you paste the access key ID, as you see here. So I'm going to copy this and paste. And the secret access key will be this part. So I have to show you this for this demo, but never show your secret access key in a video you share to others. I'm going to make sure I delete the user right after the video. So enter the secret access key. The default region name is the region name you're working from. So sometimes for services like EC2, when you say list all my EC2 instance, you'll only see results from one region, and the region you put in here will be the region the response will be coming out of. So I'm working out of US East 1. Now for the default output format, the default option is JSON. So even if I don't type anything and type enter, JSON will be the default output format. So I don't need to do anything in there. So just typed enter. At this point, my AWS credentials are set up, and I should be able to call this command and create the bucket now. So I'm gonna copy this command again and try to create this bucket. And this time I don't get an error. I just get an output saying make bucket EC2 permissions 1 2 3 4 5, which means the bucket was created, unlike here where it says make bucket failed. So to verify, I can type in a command saying AWS S3 ls, meaning list all the buckets, and enter. And I can see some of my buckets that I created earlier, as well as the bucket I created in this lab named EC2 Permissions 1 2 3 4 5. So what's wrong with this problem? What's bad with this way of getting credentials is that the credentials are hard-coded in a file. You can access the credential file by typing a command like cat, which will show the contents of the file, and a command like AWS Credentials. So I have this command in the steps here, right here, cat AWS Credentials. I'm going to type this, and this will give me the credentials that I set up earlier. So you see, the problem with this is if someone gets access to my EC2 instance, they can see this access key and secret access key, and they can use this. And user access keys are not rotated often. They're rotated like every 3 months or year or so that once someone gets an access, they have access for a while. In this case, we have S3 full access, and if a malicious user gets access to these keys, he can store multiple files without me knowing. So what is the better way then? A better way to attach permissions to EC2 is using roles, right? A better way to give permissions to your EC2 instances or the application in your EC2 instances is using roles, which lets you get access without hard coding any credentials. And let's see how that works. So first of all, let's delete this file with the credentials, right? This file that contains the credentials, let's use a command like rm for remove and credentials file. And now when I use this command to view the credentials, I don't have that file. And I don't have that file, so when I say AWS S3 ls, then it tells me unable to locate credentials. So obviously I need to do AWS configure again. So at this point I know that these things are gone, and the command is not working anymore. So let's create a role now. We'll do this in the second part of this lab. I'll see you in the second part of this lab then. Welcome back. This is part 2 of lab 4, where we're talking about EC2 permissions with IAM roles. And the part 2 actually deals with the IAM roles. In the first part, we used access key ID and secret access key to access S3 from EC2. Now let's go to the IAM dashboard and create a role. So here I'm in my IAM management console. In the left navigation pane, I'm gonna click on roles, and in the roles page, I'm gonna click on create role. In here, choose the service that will use this role. In our case, this will be an EC2 instance, so I'm gonna select this and click on next, permissions. Now in here, you would add the policies that will attach to this role, or whoever is using this role would have these permissions. Whoever is using this role would have these permissions contained in these policies. So I'm going to search for S3 full access, and also for EC2 full access. right? S3 full access and EC2 full access. And we need EC2 because we will reuse this role in the next lab. So let's select this one as well. Say next review. The role name will be S3 or EC2 S3 access, right? And allow EC2 to make S3 and EC2 API calls. And make sure you have these two, S3 full access and EC2 full access, and then create a role, and you should be ready to use this role now. So the name is, once again, EC2 S3 access. Now I'm going to go to the EC2 dashboard, and here I'm going to go to my EC2 instances. To attach the role, click on Actions, click on Instance Settings, select Instance Settings, and click on Attach, Replace IAM Role. Click on this, and on this drop down, select the role that you created earlier. Right now we only have one role, so I'm going to select this and apply. Okay, so as soon as this is applied, right, you can go to your terminal. So once you're back in the terminal of your EC2 instance, you can type AWS S3 LS for listing the buckets, and you should be able to see the buckets listed here. Now, as you saw, we weren't able to do this earlier because we didn't have the credentials. We removed the credentials file by using a command like rm something like this. Right now this file is not even there, and we are able to access S3 using roles. Now let's quickly go back to the EC2 instance. Just so you're absolutely clear on this, I'm going to go to my EC2 instance. I'm going to click on Actions, Instance Settings, Attach, Replace IAM Role, right? And I'm going to say no role, remove the role, apply, detach the role, right? I just detached the role. So once I detach the IAM role from the instance and come back to the EC2 instance and type in AWS S3 LS, I won't be able to list the buckets because the role was detached. Now, I hope you just got the idea now. Role is letting us use this command to list the S3 bucket. So I'm going to go back again and attach the role to the EC2 instance one more time. Instance Settings, Attach, Replace IAM Role, EC2 S3 access role, apply. Now if I go back to the terminal and do this, I should be able to list buckets because I have the roles now. So roles attached, you can list the buckets. Roles detached, you cannot list the buckets. So once we've made that clear, let's look how roles work actually. Right, so what happens when you use roles is roles actually use access key and secret access key, but they use a temporary access key and secret access key, right? Using the security token service on AWS. So I'm going to quickly show you this. This is like a optional section, just giving you extra information here so that things are even more clear. I'm going to type in this command, type enter, with a slash at the end, type enter, and after you type this much, whatever you see in here is the name of the role that's attached to the EC2 instance. So I'm going to copy this and bring the previous command with an up arrow and paste the name of the role / and enter. Now a command like this, which will let you query the metadata of EC2 instance. So you and I will have common command until here, and everything after here, the name of the role will be different depending on what you chose the name for your IAM role. So once you create a command like this and enter, in the terminal you'll see something like this as the result, which will have the access key ID and secret access key, just like before. But in this case, you also get something called token, which is an extra thing that is used for these temporary credentials. And this also has an expiration of 1240. After a few hours, this access key ID and secret access key will expire and something new will come up. So even if someone gets access to these keys, they are temporary. So with that, we have demonstrated how roles work and why they are a better option or a better practice than hard coding access key and secret access key. As you can see, roles are temporary, and they are not hard coded. With that, we've come to the end of this lab. We'll be reusing this instance, this EC2 instance, for our next lab. So if you want to do less work in the next lab, you're free to save this EC2 instance. I'll see you in the next lab. Thank you for watching. Welcome back. This is lab number 5. And the title of this lab is AWS EC2 Command Line Interface Commands. If you go to this page, then you'll land on the AWS Command Line Interface page, which will tell you that the AWS Command Line Interface is a tool to manage your AWS services so that you can use simple commands like AWS EC2 describe instances and list all your instances. So we're gonna do this right now with the same EC2 instance that we used in the lab before this. That I have right here. But if you don't have this EC2 instance with you, then you can create a new EC2 instance. I'll be creating a new EC2 instance because why not? So let's get started. The first step, launch Amazon Linux AMI. In the instance type, I'll stick with T2 Micro. Next, everything default here, so say next, next. Tag this as AWS CLI or something. Next, security group. I will select an existing security group with port 80 and 22. If you don't have this, you can create a security group with these ports open. Review and launch. So I select a key pair and launch. Now all of us should be in the same page, right? We either have an instance from previous lab or we just created an EC2 instance. So I'm going to give this a minute or so before I try to log in. And before that, like we learned in the last lab, we need permissions to work with even EC2 service from an EC2 instance. So for me to be able to say stop EC2 from an EC2, I need some permissions. And we did that using roles in the last lab. And similarly, we need to attach a role to this EC2 instance, and we'll go to Actions, Instance Settings, Attach Replace IAM Role, and select the same role as last time that we chose in lab number 4 with EC2 and S3 full access. I'm going to apply this, close, and at this point, I click connect. I get this connection string. Close. In my downloads directory where the PEM file is, I'll paste the connection string. Type enter and say yes when I get this message. Enter, and I'm logged in to my EC2 instance. So once you're in, so all we need to do is to configure the AWS CLI. So AWS configure, type enter. It will ask you for the access key ID. You don't need to type anything because we are using roles. So type enter. Same thing with the secret access key. No need, type enter. Now the default region is required. For me, it's US East 1. If I didn't do this, then I would have said -- region US East 1 after every single command. If I do the configure, I do it once and I don't need to put this anymore. So for example, our first command will be AWS EC2 run instances -- image -id space, and I need to provide the image ID now. I can find that by clicking on launch instance and go to Amazon Linux AMI and select this AMI ID, and image ID will be that. And one more thing that I need is -- instance type t2.micro. Now all I need to launch an EC2 instance is this AWS EC2 run instances image ID. So you need to provide the image ID and the instance type. Anything else is not necessary. You know, some default values will be applied, like the default VPC, the default security groups, and so on. So as long as you do this, we should be good. But I still have this -- region US East 1 here, just to show you that if we hadn't done the AWS configure, you know, we would need to put this at the end of every single command. I can still leave this because, you know, it's gonna work. And if I wanted to query things in the US East 2, I could do it that way instead of setting US East 2 hard-coded in the configuration. So with that, I'm going to just enter this command to show you that all I need to launch an EC2 instance is this much. Enter. And you get something as an output where you can see some of the details like the VPC ID and the private address of this EC2 instance, the security groups used, and so on and so on. So we just used one command to launch an EC2 instance, and you can find that command by going to the labs folder of our course repo lab 5. So in our lab file, step number 1 is, so this is the command that I used here to launch this instance. Let's move on to number 2 then. Let's launch another instance with Windows AMI this time, right? We launched an instance with Linux AMI. Now let's do Windows. So let's go back to the EC2 management console and click on launch instance. And in this box, let's type in Windows. That will filter out all the Windows AMIs available. And you can choose any of the AMI. So I'm going to choose the top AMI because it doesn't matter which one I choose. I just want to launch a Windows instance. So 2019 is fine, but any other Windows AMI is also fine. I'm going to choose this and go back to my command line. And I'm going to bring up the previous command with an up arrow and go to the AMI ID, replace that with the Windows AMI ID. Everything stays the same. EC2 run instances image ID. This is Windows AMI ID. And instance type of T2 micro. Type enter. And now I have a Windows EC2 instance running. And right here it says platform is Windows. So let's go to our third command, list all the instances and their details. So far we launched EC2 instances, and we should have 3 EC2 instances if you're doing this lab with me. So now you can use a command like AWS EC2 describe instances. This means list all the instances and list all the attributes the instance has, right? So type enter, and you see a list of instances, right? This is one instance starting from here to the bottom. This is another, right? And this is the third one that I have. You should have something similar if you're doing this lab with me. So we have a few instances in this, come up when we do this. What if I want to get only the IP address of my instances, right? What if I don't want to see all this extra stuff, contained in this output? Just give me the public IP address. And to do that, you'd use a command, something like this, number 4, describe and query specific things, IP address of all the instances. Go back to the command line and type in this command, and you can list out the IP addresses of all your instances. Right now I have 4 instances, and I can see 4 IP addresses. This is public IP addresses. You can do a few things while trying to query your instances. You can filter out certain instances. If you go to the management console first and go to the EC2 dashboard, click on your running instances, and there's a box here that says filter by tags and attributes or search by keyword. So when you click on this, you can filter by many things like image ID, owner, platform, etc. So if I click on platform, I get 2 options of Linux or Windows. Let's say I just want to find out what my Windows instances are. Click on Windows, and I have one instance that we just launched with the command line interface. So the same way, we can filter out things by using a command like this, which filters and gives me only the IP addresses of the Windows instance. So it's kind of like combining the concept of filter and query that we used in the last command. When we enter a command like this in the command line interface, I get one IP address, just like I did in the EC2 management console, and this matches the IP, and it should, because we just filtered out just the Windows instance. So as you can see, you can do things like query and filters and work with your EC2 instances and get quick results when you're trying to work with EC2 instances using the command line interface. So now we have done these things, let's stop one of our EC2 instances. I'm going to go back to my management console and make a note of one of my EC2 instances that I launched with the command line interface. I'm going to copy this, go back to my terminal and type in a command to stop this instance. Right? Stop this instance, AWS EC2 stop dash instances instance dash IDs, right? And paste the instance ID. So once we stop the instances, let's go ahead and make sure it is stopped. Yes, it is. And now let's terminate this instance, right? Not just stop, but terminate. And terminate means, release forever. I don't need this anymore. So bring up the previous command, and instead of saying stop instances, I'm gonna type terminate instances, enter. And now it's terminating the instance. If I go to the management console and refresh, it says terminated, and it's pretty quick. So we stopped our EC2 and we terminated the EC2, and you should know the basic EC2 CLI commands now, and you should know how to set up the CLI and how to use roles. So with that, you're free to experiment more by clicking on this link, and this will take you to more documentation and official documentation and steps. We also have a command line interface course on Udemy that covers not just EC2 but a lot of other services, and there's a GitHub repo for it. You can go to this repo. I'm gonna link this repo in the description below. Now let's do some cleanup before we stop this lab. Let's go to the EC2 Management Console, select everything except the one that's already terminated, and actions, instance state, terminate, yes, terminate, and all the instances will be terminated. Now we've done some cleanup. Thank you for watching. I'll see you in the next lab. Welcome back. In the slides, we talked about two kinds of EC2 storage, one of them being the EBS volumes and the other being the instance store. The instance store volumes are the volumes physically attached to the host machine, where your EC2 instance live. So far we've been using EBS volumes only to launch our instances. And in this lab, we'll be creating an EC2 instance with instance store as root volume. So let's get started. I'm here in my course repo. Inside the labs folder, I'm going to open lab 6, the title being EC2 with instance store. I'm going to go to my management console and click launch instance. So far we have used Amazon provided AMIs. That's all these AMIs, and also my AMIs, right? We created an AMI or a golden image with Apache Web Server installed in one of our previous labs. Now, this time we will use a community AMI, and this will give us filter for some more options with the root device type of instance store, right? So if I do this, I only get the AMIs with root device as instance store, and this will let me launch an EC2 with instance store root device type. If you click on select on any of them, it doesn't matter. You'll see a bunch of EC2 instances options grayed out, because we've seen this window a lot of times. We've seen this page a lot of times, and you may have noticed EBS only being written next to the T2 micros and everything. And that's because these instance types, T2 micro and T2 nano and this M4 extra large, they only support EBS volumes. There are some other instance types like the M3 medium that support non-EBS volumes as a root volume. In this window, I can only select these instances, and I'm going to select the one with 1.7 gigabytes of RAM because this is the smallest one available with the instance store, and click on next, and I'll leave everything as default in this window. Next, and this time you see the volume type of instance store, and I don't have any choice over the size, but I do have the instance store as the root volume. Click on next, add tags, and I'll give this a name tag with instance store EC2. Next, select the security group that we created in one of our previous labs. We just want to demo an instance store here. You can select a security group of your choice, review, and launch with your key pair. Launch, and if I click on the instance, go to root device type, I see instance store here. So we just launched an EC2 instance with instance store as the root volume. All right, so once this instance store backed EC2 instance is running, let's click on actions, instance state. We can't stop this instance because instance store backed instance cannot be stopped. Only the EBS backed volumes can be stopped. So there's not even an option to stop your instance store EC2 instance. So to clean up this instance, let's click on terminate and terminate. Hopefully this lab gave you a chance to work with instance store and launch an instance store and see how that works. We've come to the end of this lab. Thank you for watching. I'll see you in the next lab. Hey everyone, welcome back. This is lab number 7. The title of this lab is EC2 SSH authentication with username and password. Let's go to the course repo on GitHub. So the steps for this lab are, first of all, to launch and log into your EC2 instance. So once again, Let's go to the EC2 Management Console, click Launch Instance, and launch a simple instance with the Amazon Linux AMI. T2 Micro, next. Everything here can stay the same. Storage. In the name tag, I will add this as password auth test or something. Next. Now in the security group, you would want an instance with port 22 open at least. So you can create one or choose one that has port 22 open. And review and launch. Select the right key pair and launch your instance. At this point, I'll click on the instance ID here, and I'll give this a minute or so before I can click on connect. All right, so looks like the instance is ready. I'm going to click on connect, copy the connection string, go to my terminal and paste that connection string. Make sure you're in the folder with the key and enter. Type in yes, and I'm logged into the EC2 instance. So once I'm logged into the EC2 instance, we need to do a few things for us to be able to log into this without this key, and with a password instead. So the first thing that we need to do is create a password for the EC2 user. So for that, I'm going to type in a command, which you can find by going to the lab file. So this is the first command, sudo passwd EC2 user, sudo passwd EC2 user, which means with the root permissions, change the password for EC2 user. Enter. I'm going to choose a password. I chose a bad password, but I can still go on. It's just giving me a warning. But I did set a new password. Now we need to enable password authentication. So the next step is to update the password authentication parameter in this file. And this is the config file for SSH daemon. This is what lets you authenticate with the EC2 instance, and you can change the config here to set up password authentication and so on and so on. So I'm going to copy this file path, go back to my terminal, and type in sudo for super user access, vi for the vi editor, and the path of the file. So type in enter and you'll be given all this text. So we're gonna scroll down until we find password authentication. So right here, password authentication is set to no. I'm gonna change this by clicking I. I'm gonna go to the insert mode and remove this, type in yes. After this, click escape :WQ exclamation. So this is the command to quit the document, enter. And the configuration is changed now. We still need to do one more thing. We need to restart the SSHD service. And I'm going to copy this command to restart the SSH daemon, enter. And it's stopping and starting, right? Okay. Looks good. And if you're on Ubuntu, you can use a command like this. We're good with this command. So let's move on. And number 5, our next command will be exit out of the EC2 session and then log in to test the password authentication. So I'm going to type in my EC2 instance exit to come out of the EC2 instance. And instead of using the PEM file, the key to log into my EC2 instance, this time I'm going to remove the key file name. Right, so just type in SSH and username at the DNS name of the EC2 instance, enter, and it's going to ask me for the password which I set earlier, and I type the password in and I'm inside the EC2 instance without using the key pair. So this is how you set up a password authentication on your EC2 instances. So I'm in my EC2 instance, and if I type in history, then I can see that I entered a few commands in here, right? Sudo password. So I changed the password for the EC2 user. I changed the configs, and I restarted the agent. 3 commands that were used to set up the password authentication for the EC2 user. In slide number 13, we talked about how you can run commands on your EC2 during launch. So now these commands that we entered in the first part of this lab to set up the password authentication, we can enter these commands during startup, right? We can automate this process so that we don't have to do this over and over again. So that we'll put a script like this in the instance user data. And to do that, let's first of all go to the course repo. So this is the course repo, and in the lower part of the file, you'll see this script, right? Copy this script, and let's go to the EC2 management console, and we'll launch a new instance this time with Amazon Linux AMI, T2 micro instance type. Now the important page is page number 3 or tab number 3, and if you scroll down, there's advanced details section right here. If you click on it, it will expand to give you a user data portion and a box. And in this box, you can paste the bash script that will perform some actions during EC2 startup. And this section is called user data. And this is basically how you automate things during startup, right? When you can include some script that will install certain applications, or do something like set up the password authentication during startup. So in this script, what happens is, first of all, just like we did earlier, this line will go to this Sshd config file and replace password authentication no with password authentication yes. We will restart the Sshd service just like we did earlier. And I've included both of these commands, so that you can be safe, and it will work on multiple distros. So one of them might fail, the other one will work. Now in here, you can enter the name of the user that you want. You can, instead of Bob, you can have your name in here. And the password that I chose for Bob is here, but you can change the password as well. So when you choose these 2 things, or you can leave them as default, you can copy this, and a user with name of Bob and password of password123 will be created, and we can log into the EC2 instance as that user, like this. So let's go ahead, and after making sure we pasted this script in the user data section, click on next, add storage, everything as default. In the tag, I'm going to call this user data test, and next, security group. For this lab, you only need port 22 open. Select the security group, review and launch with the right key pair name. Launch instances, and then you click on the instance name, bring it up, and give it a minute or so before it's ready, and we'll try logging in with the username of Bob and password of password123 without using PEM files, right? Because we set up this during startup using user data. Looks like the instance is ready to be logged into, so I'm gonna copy the public IP this time, right? All I need is the public IP. Copy the public IP, go to my terminal. I'm gonna go to my downloads folder. I'm going to SSH with Bob as the user at this IP and type enter. All I need is this, say yes, and I'm asked for password. The password for me was password123, and I'm in with the password that was set up during startup using EC2 user data. So you should be able to do the same thing if you follow all the steps, and you can go back and watch this video to see exactly how everything was set up. If you have any questions, don't forget to ask. But after this, we're good to move on to our next lab. So let's do some cleaning real quick. I'm going to go to my EC2 management console, select both the EC2 instances running, actions, instance state, and terminate. So that will clean up those instances. Thank you so much for watching. I'll see you in the next lab. Hey everyone, welcome back. In the slides, we talked about how you can monitor things like memory utilization of your EC2 instance using custom scripts and using agents. So in this lab, we will install the Cloudwatch unified agent on our EC2 instances that will let us send not only custom metrics but also logs to Cloudwatch. So let's get started. So I'm here in my course repo inside the labs folder. I'm going to click on lab 8. Before we begin, we have to start by creating a role for our EC2 instance that will let us, update the Cloudwatch with custom metrics and logs. So we need to add some permissions to our EC2. So we'll start by creating this role, and we'll add a permission contained in this managed policy, Cloudwatch agent server policy. So I'm going to copy this name right here. I'm going to go to my AWS management console and type in IAM here. Once you're in the IAM management console, click on roles. So create a role and choose the service that will use this role. It's going to be EC2, next permissions. And in this page, I'm going to paste in the policy that I copied earlier from this lab file. I'm going to check on this policy, which will let our EC2 instance, update the Cloudwatch service with custom metrics and logs. So next tags, next review, give this role a name of EC2 Cloudwatch agent role, right? And role for Cloudwatch agent on EC2, something like this. Make sure you have the right policy. We do. And create a role. Launch an EC2 like we have been doing in the previous labs with port 80 and 22 open. And I'm going to click on launch instance with Amazon Linux AMI, select T2 micro as instance type. Next. No changes here except for IAM role. This time we'll select it right here. IAM role of EC2 Cloudwatch agent role. This is the role we created earlier in this lab. So select this. Next, add storage. Everything as default here. Click next, add tags. In the tag, let's give it a name tag of Cloudwatch agent EC2, something like this. Next, configure security group. I'm going to select a security group with port 80 and 22 open. Review and launch. Launch. Select the right key pair that you have. Acknowledge and launch. All right. So at this point, we have a EC2 instance, a basic Amazon Linux EC2 instance launching. I'm going to click on the instance ID and give it a minute or so. And then in the meantime, let's go to the lab instructions. And step number 3 is SSH into the instance. We're going to do that right after this. But step number 4 is, depending on what Linux distribution you're using, or what operating system you're using, you have to download a different link. So if I open this link, you can scroll down and find, your platform that you're using. We're using the Amazon Linux AMI, so we'll use this link. So copy this link. Now let's go to the EC2 management console, click on connect, copy this connection string, go to our terminal. Once you're in the terminal, paste the connection string, say yes, log into the EC2 instance, and at that point, like mentioned in the lab steps, use the wget command to download the Cloudwatch agent. Now I have this command prepared with the link for Amazon Linux, and all of us are using this, so we can use this command, but you can look at this file as a reference. You can go to this link as a reference and read more about this. So I'm going to copy this command go to my terminal and type enter, and this file is now downloaded on my computer on my EC2. This file is downloaded on my EC2 instance. If I list the directory, I get this file. Now the next step is install this package, which is Cloudwatch agent. So this command will install the agent, and finally I need to configure this agent. Right now, watch this step carefully. We need to configure this agent before we can run this agent. So I'm going to copy this command that I have, which will open the Amazon Cloudwatch agent config wizard, which will give you some options that you can choose to configure the agent properly. So I'm going to copy this command from the lab instructions, go to the terminal and paste the command. As soon as I paste, I'm given an option on which OS are you planning to use the agent. The default option is 1. I'm going to go with Linux. Are you using EC2 on premises or host? I'm using it on EC2, so I'm going to type in enter, which is the default choice. Do you want to turn on Stats-D daemon? I'm going to say no, so type 2, enter. Do you want to monitor metrics from collect D? I want to say no again, so type 2. Do you want to monitor any host metrics, example CPU, memory, etc.? Yes, so I'm going to type enter for the default choice. Do you want to monitor CPU metrics per core? I'm going to say yes, so enter for default choice. Do you want to add dimensions? I'm going to say yes to this, so default choice. For this one, high resolution, I'm fine with 60 seconds, so I'm going to go with the default choice, enter. Which default metrics configs do you want? I want to go for basics, so just type in enter. Are you satisfied with the above config? I'm satisfied, so I'm going to type in enter. Do you have any existing Cloudwatch log agent configuration files to import? For now, no, so I'm going to go with the default choice of no. Do you want to monitor any log files? Not right now, so I'll go with choice 2, enter. Do you want to store the config in the SSM parameter store? I want to say no, so I want to type 2 and enter. And the agent will be now configured. So if you missed some step, make sure you go back, rewind, and look at my choices. So make sure you configure the agent, and once you configure the agent, we have to start the agent. And step number 8 in the lab steps, I'm going to copy this, and this command will start the agent and also give the path to the configuration file that's generated by the wizard. So copy this command into your terminal of your EC2 instance, and I get a message saying, Amazon Cloudwatch agent start running, right? So something is running. So after a while, we should be able to look into some of the EC2 memory metrics, which by default are not collected by Cloudwatch. So by using this agent, by configuring, installing, and starting this agent, we should be able to now collect EC2 memory utilization. So let's wait for a couple of minutes. Type in Cloudwatch under services. Now I'm here in my Cloudwatch management console, and if I click on metrics, under all metrics, you should see something like CW agent here. After a while, obviously after 5 or 10 minutes, if you check in, that's what I did. I came back after 5 or 10 minutes in. If I click on this, I can go inside of this and see, memory use %, and it is being reported every 5 minutes, 2020, 2025. So I can track my memory utilized metrics as well as CPU utilization metrics, which Cloudwatch tracks by default. So memory does not come with a default setting, so we do something. We install the agent to get these memory utilization metric. The Cloudwatch agent is a lot more powerful than just collecting memory utilization metrics. It can collect a lot more things. So you can try it out. You can read more on the Cloudwatch agent and do more things. But for now, I hope you got this demonstration of how to collect and visualize memory utilization and any other custom metric with Cloudwatch agent. We'll be using this EC2 instance in the next lab as well. So you're free to keep this EC2 instance, but you're also free to clean up the EC2 instance and you can start over with a new EC2 instance in the next lab. Hey everyone, welcome back. This is lab 9, and in this lab we will be using the Cloudwatch agent to send Apache Web Server logs to Cloudwatch. And we'll look at the logs in the Cloudwatch management console. So we'll build on some of the things that we did in lab 8, where we installed the Cloudwatch unified agent. We just need to reconfigure the agent to, work with logs and collect logs sent from our Apache Web Server. So let's get started with the lab. The first step for lab number 9 is we need to install the Apache Web Server and start the web server, so that it starts generating some logs when someone tries to access the web server. So I'm going to copy the command that will install the web server, and we've done this in labs earlier. I'm going to copy this command, go to my EC2 instance from our previous lab, and paste this command and install the web server. So I've entered this command already. Now I need to start the web server using this command. So I'm going to start the Apache web server. The web server is started. At this point, I go to my EC2 management console and I go to my EC2 instance, right? I copy the IP and go to that address on my browser. I should see a page that says, Amazon Linux AMI test page, which is shown by the Apache web server, right? So this is the web server landing page. So this should generate some logs now. See, I've clicked this 4 times. So if I go back to my terminal and use this command, sudo cat for view this file, var log httpd access log, this is where Apache saves the access log. So if I copy this command, go to my terminal and paste this, I'll be able to look at all the logs generated by the web server. These are some of the logs generated by my web server. So these are some of the logs generated so far. So what if I want to send them to Cloudwatch? I can use the Cloudwatch agent that we installed in lab 8. So we need to reconfigure the Cloudwatch agent with the wizard again, right? So I'm going to copy this command to bring up the configuration wizard. Which OS are you planning to use the agent? Linux, so enter for default choice. EC2 for default choice. Do you want to turn on stats D? No, so 2. Collect D? No, so 2. Do you want to monitor any host metrics? For now, I'm worried about the logs. We already demoed metrics, so I want to say no at this point. 2. Do you have any existing Cloudwatch log agent? I want to say no. 2. Do you want to monitor any log files? Now in here, I want to say yes. So the default choice is 1. So I just press enter. And the log file path. Now this is where I enter the path of the log file. So this is the path on step number 3. So I'm going to enter this path. Enter. Log group name, the default choice of access log is fine. Enter. Log stream name, instance ID, that's fine. Enter. Do you want to specify any additional log files? For now, no. So I want to say 2. Do you want to store the config in SSM parameter store? No. So 2 and enter. And the program exits. Okay. So once I configure the wizard, I need to restart the agent. And I come to step number 5, copy this to restart the agent and paste this, and the Cloudwatch agent should be restarted now. So what we did so far was we reconfigured the agent to collect logs from the Apache log file location. and then we restarted the agent. Now we want to go back to this web page, the default Apache web page, and generate a couple of logs by refreshing our page, right? So 1, 2, 3, 4, 5. So this should generate a few log entries in the log file, and those log entries should be sent to Amazon Cloudwatch. So if I go to services and click on Cloudwatch, and under logs, there's already an entry for access log and the instance name, and I can see all the log entries that is tracked by the Apache Web Server. And in fact, I can 1, 2, 3, 4, 5. So 5 more entries, and the entries are already there. See? So it's pretty quick. The entries are they are fairly quick. There's a few more entries coming in. So this way you can send your logs from your EC2 instance to CloudWatch. And if you have any questions, please don't hesitate to ask. So with this, we've come to the end of this lab. Now, as always, we need to do some cleanup. So I'm going to go to EC2 and I'm going to delete or terminate my instance. Terminate, yes, terminate, and I'm good to go. So this concludes the lab. Thank you for watching. I'll see you in the next lab. Hey everyone, welcome to lab 10. In the slides, we talked about the different kinds of AMIs or Amazon Machine Images, and the different types being AWS provided AMIs, community AMIs, your custom AMIs, and AWS Marketplace AMIs. We have used the AWS provided AMIs, a lot. Community AMIs when we launched the instance store backed EC2. Custom AMIs when we created a golden image, but we haven't used the marketplace so far. So for lab 10, we will install WordPress using AWS Marketplace. So let's go to our GitHub course repo. And in the course repo, I'm inside the labs folder. I'm going to open lab 10. So in lab 10, we'll use the marketplace to install one of the WordPress applications using a marketplace AMI. And we'll also implement some small features on our EC2 instance that we launch. So first of all, let's go to our EC2 management console. I'm going to click on launch instance. And on the left side, we have done this with our Apache Web Server. Community AMIs, we've done it. Now, AWS Marketplace. So in the marketplace, you can find infrastructure softwares, developer tools, and business softwares. What we are interested in the marketplace is the WordPress Bitnami. So this is a WordPress certified by Bitnami and Automatic, which is the company behind WordPress. So we're going to use this AMI from the AWS Marketplace to launch a WordPress instance. So I'm going to click on select this one. And as you can see, you won't be paying anything for the software itself, but you'll only be paying for the EC2 that the AMI will launch. So this will just give you an overview of what you can expect paying. Click on next, select the T2 micro, next. Everything else can stay as default. Next, add tags. In the tag, I'm going to call it WordPress instance. Configure the security groups. It should come pre-populated with the required ports, so I'm going to leave this as it is. Review and launch. Once again, you can review the software fees and things like that. In this case, there's no fee. Launch and select the right key, acknowledge, and launch instance. So this way we just launched an EC2 instance with an AMI from the AWS Marketplace. Now, while this instance is launching, if we quickly go to the Marketplace by saying launch instance and Marketplace. You can also see things, costing 5,000 per year and 50 cents per hour, 10,000 per year, and so on and so on, right? So there are things in the Marketplace that will cost you a lot of money, but in this case, our Bitnami WordPress AMI was free. We didn't pay for that. So you're free to explore the Marketplace and see what else is in here. But for now, let's go back to the EC2 dashboard. So the WordPress instance has a public IP of this. If I go to the public IP, it's not ready yet, so it should take a minute or so before it's ready. So after a while, when I press enter, I'm taken to this application, which is a WordPress application running on the EC2 instance. So the AMI comes with this application installed. Now we want to log into this application just to demo this a little bit. Here's a page to manage. Click on this and it'll tell you to get the password. The username is going to be user, right? The username is going to be user, but the password, you can follow these instructions to get the password. Now the link to get the password is also in the lab steps. You can go to this link and find out how to retrieve the password. But basically, to find the application credentials for your WordPress website, you need to go to EC2 dashboard, select your instance, and under instance settings, click on get system log, right? So let's do that on our end. Actions, instance settings, get system log. I'm going to search for a password. I'm going to scroll down and you'll find a section like this. It says setting Bitnami application password to this. So this is your password. So this will be different for all of us. We should have different passwords, but for my instance, this is the password. My application, this is the password set. So I'm going to copy this password and go back to my application page, that I browsed by putting my public IP. And after the IP, say //admin to go to the admin page. And the username will be user for everyone. The password will be the password that we copied. And there it is. I'm able to log in. And this is my WordPress management dashboard. If I click on post and say add new, and I can write a blog, my first blog, hello world, right? So something like this, and I can publish my first blog, this quick. I just launched my instance. I can view the post, and here it is, my blog, right? So you can give this IP to anyone and they can view your blog now. So this is a demo of us using the AWS Marketplace to launch applications in the cloud on AWS, hosted on EC2 instances. Hopefully you get an idea of what you can do with the Marketplace AMIs. All right, so once we have that, right, once we have the website, let's say that I actually start, putting more posts on this website and a lot of viewers start coming in. I want to protect this instance and the data in here somehow. So I want to demo a couple of features for you, EC2. One of them is termination protection, which will, stop people from terminating this instance accidentally. So I can go to actions, instance settings, click on change termination protection, and I can enable termination protection so that people can't just terminate this instance by mistake. So when I click enable, and if someone goes to actions, instance state, and by mistake clicks on terminate, they can't actually terminate because the button is grayed out. You cannot do that without disabling the termination protection. So that's one feature that I wanted to demo. The other feature is, how do you back up your blog? Let's say you add a few more posts and one day, your instance is broken and you lose all your data or something. How can you protect your data? You can protect your data by backing up your EC2 instance. So you can do that by going to your instance, scrolling down, and you find the device, the root device of the instance, the volume right here, right? Volume. So you can go to the volume for your EC2 instance, click on Actions, and create a snapshot. The description can be something like WordPress snapshot. And you can just click on Create Snapshot. And this will create a snapshot for you. All right, the snapshot is completed. It took maybe 2 minutes to get this done. So once the snapshot is complete, the snapshot is just a file, stored in S3. But if you click on Actions, you can create a volume out of the snapshot. So you can select the size of the volume to create from the snapshot. You can choose the availability zone and just say create volume. And the volume will be created with the snapshot. See, this volume is created from the snapshot. So this way, you can back up your WordPress instance and you can protect this from accidental termination. And by the way, if you eventually want to delete this instance, all you do is say instance settings, change termination protection, and disable, right? Let's all do this because we want to clean up. We're done with this lab now. So disable, and once you disable the termination protection, you can go to Instance, Actions, State, Terminate, and you can terminate this time. So terminate the instance, go to Volumes on the left navigation pane, select the volume that says available, delete the volume. The other volume is from the EC2 instance, so that should go away by itself. Go back to the EC2 dashboard and make sure you don't have any EC2 instances running. You don't have any volumes. This should go away in a while. And you can go ahead and delete your snapshots as well. So after a while, the instances got terminated. It took a while for them to terminate. But after the instance is terminated, I can go back to my EC2 dashboard. And at this point, I should not have anything here. Keep here, they do not cost money, and security groups don't cost money. So I'm fine with them being more than 0. So I still have one more snapshot. And if you go to the AMI in the left navigation pane, we created this AMI. The AMI actually creates a snapshot. So if you deregister this AMI that you have, at this point you should be able to delete the snapshot as well. Delete the snapshot. Make sure all the resources you provisioned in this course, in these labs, are gone. And if you have any questions, don't hesitate to ask. And that brings us to the end of this lab and the whole lab series. I hope you learned a few things about EC2 after taking this course. We plan to improve this course as we go on, so your feedback is highly appreciated. Please don't forget to add reviews and put some feedback that you have. We have some extra information for you to check out in the next video for our other courses and other places that you can find us at. Thank you so much. I'll see you in the next video.